Section 1.4, rational expressions. So we're going to do several things in this section. The first thing is, how do we simplify a single rational expression? Well, you want to try to come up with all possible factors of the numerator and denominator, and then if any factor repeats on the top and on the bottom, they can be canceled out, becoming a 1, and you're left with, well, whatever remains on top of the numerator and in the denominator. So let's look at a couple of examples. Example number 1. First thing is to factor the top and the bottom of this rational expression. So again, we got to be able to factor. All right. So the top here becomes what? 2x minus 3, I think, then x plus 1, right? Make sure you check that. Make sure if you were to FOIL these two binomials together, you should, of course, end up with this trinomial. All right, now we're going to factor the denominator. So let's see what we get. And then we only have a 1 to work with. And so what should the signs be here and here? Well, has to be a negative in the middle, negative 1x, and then outside product would be positive 2x. That makes sense because negative 1 plus 2 gives you a plus 1 plus 1x. So there's the correct factorization. And now you can see in this example that these two linear factors repeat both on the top and the bottom, so they are eliminated. Therefore, the answer is 2x minus 3 over 2x minus 1. All right, example number 2. Same idea. In example number 2, what we're going to do is factor the numerator and the denominator. So this one's perhaps a little bit trickier because you got a 6 in front here. Well, you can use the technique I presented to you in section 3, or you can just play with it, use the trial and error method. Doesn't matter to me. Just make sure you're able to factor this. Okay, so I'm seeing, let's see, we need an 11x in the middle. So how about this? Let's see. How about 2x times 3x is 6x squared? And then what if I use for the 3, what if I put a 3 here and a 1 there? Make them all positive. Does this work? Let's check. Inside product is 9x. Outside product is 2x. Does 9x plus 2x add to 11x? Yes, so we're good. This is the correct factorization. In the denominator, you should recognize that this is a difference of 2 squares. So the square root of 4x squared is 2x. The square root of 9 is 3. And then we do what? We alternate the signs. All right, so after we factored it, we see if we're able to simplify it. Are we able to simplify it? Do any one of these factors repeat on the top and on the bottom? Yeah, the 2x plus 3 factors repeat, so they're eliminated. Final answer is 3x plus 1 all over 2x minus 3. Let's add one more to the mix. Let's do a bonus problem. Still looking at this concept of simplifying simplifying a single rational expression. So what if I gave you this? What if I gave you 12x minus 6 on top all over 10x minus 5? Is this completely simplified? No, it is not. Again, what should we be able to do? Well, or what are we always looking for to do, I should state? What are we always trying to do here? We're trying to see if we can factor the top and the bottom. Okay, so what's the first thing we always do? Don't forget, we look for a GCF. So let's do that. GCF on the top is a 6, and we're left with 2x minus 1. And then on the bottom, can we pull out a GCF here? Yep, 5. And guess what? We get the same factor to repeat. They are canceled out. The final answer then, when we simplify this rational expression, is 6/5. The next thing we're going to do in this section is look at the multiplication and division of rational expressions. So it's basically the same idea, except now you're throwing in the operation of multiplication and, of course, division. So what I mean by that is you're still going to, given a multiplication type situation, you're going to still factor everything. If something repeats, then you eliminate it. In other words, if again repeats on the top and the bottom, they are canceled out. And then you multiply numerator times numerator, and then denominator times denominator. Only do that after you have factored and reduced. For division, there's just obviously, an additional step here. When you divide fractions, what's the rule there? Well, it's keep, change, flip, right? Keep, change, flip. So definition of division, right, is the multiplication of what? The reciprocal of the second expression, the second rational expression. Again, you're going to, at this point, after you get here, factor and reduce if possible, and then multiply numerator, denominator. All right, let's take a look at some examples. So, number one, operation is multiplication. So your first move is to factor first. Always try to factor first. So GCF just of this expression is a 4, and you get x plus 3. All right, what about this one? Can we pull out a GCF here, just in this single numerator? Yes, you can. It's a 3. So you get 3 times x plus 2. All right, at this point, does anything repeat on the top and on the bottom? Yeah, the x plus 2 repeats. And then actually, you could reduce this 4 over 2 to a 2 right now if you really wanted to. Or you can leave it like it is. Doesn't make any difference. If you left it like it is, I'll go ahead and do that. If you left it like it is, you would do everything in the numerator, times each other. So 4 times the quantity of x plus 3 times 3. What is the product of those 3 expressions? Well, 4 times 3 is 12, and then you just put the quantity of x plus 3 next to it. So that's what you get in the numerator. Now, in the denominator, you get 2x minus 1. You could actually leave it just like this. I don't really care, nor does WebAssign. Or if you wanted to completely simplify it, really, the preferred answer is this. The preferred answer is the distribution of the 12 to the quantity of x plus 3, giving you 12x plus 36 on top, all over 2 minus 1. This is the preferred answer, but either one is acceptable, okay? All right, number 2. And number 2, notice that you have a division operation occurring. So the first step is to keep, change, flip. All right, so your first step is to keep, change from division to multiplication, and then flip it. All right, now after we've accomplished that, everything's handled exactly the same way. So what is the same way? What do I mean by that? You have to factor everything if possible. Again, always look for GCF first. If one doesn't exist, which the only GCF here would be a 1 for all these, you would factor each of these 4 trinomials. All right, so this factorization would be what? X minus 3, x plus 1. Factorization here. Factorization of this one would be what? X minus 3, x plus 2. And then let's look at the second rational expression, factorization of the top and of the bottom. We know there are x's everywhere in the first spot. Now the factorization of this one. 2 factors of 8, whose sum is negative 2. Well, that would be negative 4 and plus 2. Negative 4 times 2 is negative 8. And the sum of negative 2 and the sum of negative 4 and positive 2 is negative 2. All right, last one. Again, 2 factors of 8, whose sum is negative 6. Now you're getting a negative 4 and a negative 2, right? Because negative 4 times negative 2 is positive 8. And the sum of negative 4 and negative 2 is negative 6. So after you have rewritten the division problem into a multiplication one. After you've factored everything completely, then you do what? You try to reduce, right? Anything that repeats on the top and on the bottom is eliminated. And it could be anywhere. Notice x plus 2 in the first expression, and you have an x plus 2 in the second expression. As long as one's on the top and one's on the bottom, get rid of them. And then also these. And so what are we left with? What are we left with? We are left with x plus 1 all over x minus 2.